Hello, I'm Josie, and today we're going to be identifying an unknown compound. In our organic lab, we were giving a test tube with a certain compound. Mine was labeled AG, and it was a test tube of white crystals. To determine the identity of this compound, three things were done. The melting point was determined, its IR spectrum was interpreted, and the solubility of this compound in water was also tested. To test the melting point, a small portion of the unknown was crushed, and a capillary tube was placed in the compound, and then at the end, and then it was compacted into the end of the capillary tube, and then the melting point was determined. The compound began melting at 40 degrees Celsius, and then it completely melted at 47 degrees Celsius into a clear, colorless liquid. The solubility was also tested in water. When the compound was placed in water, it did not dissolve, meaning it was not soluble in water. The IR spectrum was also interpreted, and in order to do this, a pellet was made using KBR and a small portion of the unknown. They were both ground finely using a mortar and pestle, and then they were placed into what is called into a hand press to form what is known as a KBR pellet. This KBR pellet was left in the collar of the hand press, which was placed in the instrument to read the IR spectrum. And here you can see the IR spectrum. This is what the IR spectrum of the unknown compound looked like. Right through here in this region, it's wavelengths of 1690 to 1750. It's a C double bond to oxygen stretch, which is also which is known as a ketone. And then all through here, and then up through here as well. These are C to C stretches in a ring, also known as benzene rings. The wavelengths of these can range anywhere from 675 to 870 to 1500 to 1400. Right here is like a big dip, and usually that would be known as an alcohol group, but in this case the sample somehow had gotten wet, which will produce like this huge gap right here, causing the IR spectrum to look like this. However, for our unknown compound, it does not contain an OH group. If the sample had been completely dry, this would not have shown up on the spectrum at all. It would just look more like this, starting out at the top, just showing you more of the C to C bonds. So after the interpretation of the IR spectrum, testing the melting point and the solubility, the unknown of the compound was found to be this. Benzophene. This is the structure of benzophene. It's two benzene rings and a ketone right here, which are the functional groups. Its mass is 182.2 grams per mole, and it has 13 carbons, 10 hydrogens, and 1 oxygen. As previously mentioned, its physical appearance is white crystals. It has a melting point of 48 degrees Celsius, and I found the melting point range to be in between 40 degrees Celsius and 47 degrees Celsius. And the solubility in water, as mentioned before, is not soluble. However, this compound is soluble in acetone, acetic acid, benzene, and methanol. So once that I had determined that this was my unknown, I double checked it by finding the percent C, percent H, and percent O of this compound and comparing it to a given percent C and percent H. To do this, I took the mass of carbon, which is 12.01, and times it by 13, which is how many carbons are in this compound. And I got 85.69%, which matched the given percent C exactly. The percent H was found by taking 1.008 times 10, which is how many hydrogens we had, to give 5.53%, which also matched the given percent H exactly. And then the percent O was also found, which was multiplying 16 times 1 oxygen, and that gave us 8.78%. By adding up these three percentages, it equaled to 100%, which just helped determine that the unknown compound was benzoform. I found that benzoform is to help prevent ultraviolet light from damaging scents and colors in products such as like perfumes and soaps. And this allows products like that to be packaged in clear glass or plastic. If it wasn't for the benzophore, these products would have to be packaged in dark packaging so that they wouldn't decompose due to the light. And then benzophore is also used in cosmetics, hairsprays, and hair dyes, but it usually just depends on what type of variant of benzophore is being used. So that is my unknown. That's the identity of my unknown, and I hope you enjoyed my video. Thanks.